Let's talk about fulfillment. To fulfill user queries, Cymatix platform uses Python script. By default, all inferences are returned to the application as JSON objects. Normally, applications should parse them and act on user requests. Alternatively, developers could implement some of the functionality on backend through fulfillment mechanism using available tools with short-term inference stack and also user instance and application persistent storages. We'll talk about the functionality and API that can be used. Let's consider example when user is asking time. We would have three samples here. As an example, what time is it? What time is it now? Time, please. Let's also assume that this is self-contained statement, so we can use prefix f not to keep the inference in the inference stack. And to fulfill this request right here on backend, we need to create another section. This section is called gate2. It is execution unit where we can put our Python script to execute or fulfill our request. If intent is equal what time, we would create another slot and value we will calculate dynamically as datetime, like so. What do we need to know here? Object O is a mutable object presented as a namespace containing all including current inferences. Tintent field is a reserved field for intent value. Ttime is something that we want to create dynamically and assigned with the current time in the current time zone. What we did here, we actually added parameter ttime into object O and also updated inference history. Any manipulation with O object has effect on inference history, so you can add fields or parameters or slots or change them or completely remove them, which gives ultimate flexibility to control inference stack. Another object that exposed into Python environment is object C. It's very similar to object O, but object C represents only the current inference, which would work in our case as well. So if we would change object O to object C, it basically means the same thing. This object also mutable and any field in this object could be changed. All the changes in object C have effect on inference stack. Both objects O and C are exposed in local context in Python environment. To make it even more flexible, we introduce also this section called script. Here you can define the number of functions that you need to fulfill the script. For example, in our case, we could have created the function getTime and pass locally available object O and then return the value of available API call to the script. Something like this. At the very end, we want to be able to present the prompt to user. Like so. Let's train it and take a look what's going to happen. Let's upload the project, train it. Now we can try it. What time is it now?
The time's 14:34.
The inference would contain correct intent and dynamically created prompt. Here's a list of reserved fields in the object O, which mirrors the content of inference stack. It is intent, previous intent, and prompt. Please note that intent is a string value of current intent, or the last intent in the inference stack. Previous intent is also a string, but the prompt is the list of previous prompts. In general, with the exception of tintent and tprevious intent, all other parameters in inference stack or current inference are presented as a list. For example, ttarget would have a list of values, and to access certain values you have to use index. Script section does not have full access to available Python functionality in standard libraries. Instead, we exposed only a limited number of functions that's suitable for fulfillment. You can take a look at that documentation and review them. We also added some additional functionality to manipulate the object. You can convert it to JSON format or to namespace or to dictionary. Please refer to the documentation for details. In Cymatix platform, we have a notion of NLU virtual machine or instance. Every project is considered an application, and application can have instances associated with each user or client. And each client is assigned with session ID, which we discussed earlier. Another section to discuss is dedicated for local Python variables. Section vars is to allocate local runtime context variables for each instance. For example, we would allocate section vars and variable loaded. Then in section gate, we would check the value of this variable and perform appropriate actions to initialize the instance of our application. To read or write instance permanent data, we expose session ID, which could be used like this. Or to read the data from user instance permanent storage, we would do something like this. Making sure this is not shared memory, which means it does not belong to application, but this particular instance. Please be aware of racing condition that could happen when multiple instances write into shared permanent storage. In lesson 2, we discussed utterance generation and the sections associated with it. In the S-list section, we can define multiple variations for allergy type, and at the same time this variable will be exposed in a Python global environment like so. Those definitions are equivalent. We would have G allergy type variable in Python environment, and also we would have allergy type macro available for training purposes.